Hi there, thanks for joining us yet again for another episode of Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Hope you're well. Thanks for your company. Today, we're going to try and understand the Martian moon of Phobos. Was it born of a collision like our moon, or was it captured? And what's going on inside? Might be the only way to find out what it really is. We're also going to look at an exoplanet that my wife would adore. My wife loves salt. Like, you give her a glass of ocean water and she says, "Can you put salt in that, please?" This is, I'm not joking. This is an extraordinary planet, and we'll tell you why. And a very swift mission to save a vital space observatory. That'll make sense when we explain it all on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And with us once more is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Hello. Nice to see you again.
You.
Yes, you too.
We could do the whole show just talking
rubbish
like that. Yeah, well, we do that anyway.
Yes, I've forgotten that.
Indeed.
Yeah.
We've got some really interesting stories. Mars always fascinates me, but the moon Phobos in particular. And we've got a salty atmosphere in an exoplanet, which I haven't told my wife about because she'd probably want to go there. And a mission that's got to get off the ground ultra quick to save an observatory in space. I really, really am looking forward to that story. But let's turn our attention to the Martian moon of Phobos. I did a little bit of research, and it is apparently the closest orbiting moon of any planet in our solar system to its parent planet.
That's not a surprise.
6,000 kilometers from the surface.
Yeah. In fact, it's got this peculiar aspect that it orbits Mars, of course, being a moon of Mars. It's the bigger of the two moons of Mars. It's only 23 kilometers across, so it's not really what you call a big moon. But it's got this extraordinary thing that it goes around Mars once in 7 hours and 39 minutes. But Mars takes 24 hours and 40 minutes to rotate once on its axis. So this moon in Mars's sky goes backwards. Its own motion is enough to overcome the rotational motion of the planet. So it's it goes more or less around twice a day. In fact, getting on for 3 times a day. In fact, more than 3 times a day. My arithmetic's not very good at the moment. It's quite remarkable that you've got this phenomenon. So, a very unusual moon. It's been known since, I think it was the 1880s. It was discovered actually by somebody who was related. There's a curious link. There's an uncle of Venetia Burney, who you might remember was the young woman at the age of 11, I think, who gave Pluto its name.
Oh, yeah.
And she was in Oxford, and her uncle discovered the 2 moons of Mars. Very small objects, as I've said. Since that time, everybody's wondered how they got there, partly because they are small enough that that it's possible they've got multiple different origins, not simultaneously, but they've originated in a variety of ways. That's the possibility. So the 2 theories, one is, more or less what you've alluded to already. One is that there was an event similar to the event that created our own moon, a collision in the early solar system by Mars with another smaller object that sort of bashed into it, lifted a whole lot of debris which coalesced to form the orbit of to form the object Phobos. And the other theory is that it's a captured asteroid. And I guess in the case of Mars, that's got some attractions to it because Mars of course, is right on the inner edge of the main asteroid belt. So not very far from Mars, there are lots and lots of asteroids lurking. And we know from the way Jupiter's great gravitational pull tinkers around with that asteroid belt that once in a while they stray from the main belt and you might get a capture. It's also been known for a long time to have a peculiar composition. Its density is very low, and the suspicion is that it's made of something a bit like pumice. Remember pumice being the material that is formed when volcanoes erupt underneath the ocean. You get this aerated stuff, so almost like a foam. And so its density is low enough that people don't really know whether that's what its interior's like. And of course, the other possibility when you've got something with a low density like that, in common with many asteroids, is that it could be a rubble pile. In other words, something that's just made of loosely bound material, all sort of stuck together by its own gravity, very feeble gravity because it's very small. I have to say, Phobos doesn't look like that. It does look like a more solid object, and it's got surface features including several quite big craters and one very big crater, which is called Stickney. I think it's about 7 kilometers across, and in an object that's only 22.5 kilometers across, I think it's 22.2 actually. That is a big crater. So all these factoids come together to make us wonder how it got there, what it's made of. And just one other comment about its orbit. Its orbit around Mars is not stable over a long enough period of time, and I think we're talking a few million years perhaps. It will probably collide with Mars or just be pulled to pieces because it will get within the Roche limit of Mars. That's the limit within which a solid object can't exist. Or a solid object of any given size can't exist because of the gravitational disturbance. We've talked about Roche limits before, I think.
And if it is pumice-like, there's every chance it will sort of crumble in the sky.
Yes, that's right. Not a solid object that would resist tidal forces is technically what they are. Tidal forces are when one end of an object feels a different gravitational pull from the other end. And so, yes, tidal forces would perhaps deal the final blow. But yes, so studies looking at what Phobos is made of. And I guess these are coming out and the interest is growing in advance of an upcoming space mission, which is being launched by the Japanese Aerospace Exploration Agency, JAXA, and it is called the Martian Moons Exploration. It's otherwise known as MMX, and it is a Phobos sample return mission. So that clearly this mission is expecting to land on the surface of Phobos. It will launch later this year, and it will, what the pundits are saying is it will attempt a quasi-stable orbit around the tiny moon. This is a difficult task because there is truly no stable orbit around Phobos. And the reason for that is that you've got this thing with such weak gravity that getting something into orbit around it would be a challenge in the first place. But right next to it, 6,000 kilometers away, as you've said, is a large planet. Not a large planet by planetary standards, but a large by the standards of Phobos. So lots of challenges there. And I think hopefully it'll be something we will cover over the next couple of years or so to find out what is happening with Phobos.
And I understand that to try and figure out how it became Phobos is everything to do with what's happening inside Phobos.
That's right, yes. There's one, so there's a suggestion that it may actually have a large ice content as well as rock, but we just don't know about that. There's also, I think, there is suggestion too that there's a higher density region underneath this crater Stickney. And you can sort of imagine that would be the case if you've got something which is like a piece of pumice or a kind of sponge-like structure, you get a large-ish object clouting the surface, which is probably what caused Stickney. You're going to get some compression, what you might call a localized zone of densified material, as the authors of this paper, which has appeared in the monthly notices of the Royal Astronomical Society.
Yeah, well, when you look at the close-up image that came from NASA JPL, it doesn't look. I don't know how you'd describe it. It's, it's got a potato shape about it, but it's got. It almost looks metallic in some respects.
It does. That's correct. It's got. And I guess what you're looking at is kind of the same things that I see when I look at it, and that is craters with relatively sharp edges to them, on the scale that we can see. And, that doesn't sound like something made of pumice if you've got craters that have got well-defined edges. So many mysteries. We came close to knowing more quite a few years ago. It's probably a decade ago now. Do you remember Phobos Grunt?
Yes.
Which was a Russian spacecraft that was going to go to Phobos and bring back a sample. Phobos Grunt, Grunt is effectively the Russian word for ground, or, landing on the surface. And it failed because it got into orbit, but the spacecraft that was going to push it in the transfer orbit to Mars didn't work. And so eventually it just re-entered back into the Earth's atmosphere. It was very sad. It was, a mission which we expected great things from. So maybe
the engines didn't fire properly.
I think that was right. Yes, that's right.
And it just got stuck in low Earth orbit, and that was the end of that.
Yep.
Yeah, it happens. It happens.
It does. We hope it won't happen with MMX, the Japanese mission.
No. Well, you can never say never, but hopefully it will be very successful, and we will learn more about Phobos and what makes it tick. Which way do you lean? Solid object that got captured, or a collision type of event?
I didn't know it ticked. Anyway, no, never mind.
Well, I hope not.
Yeah, I do too. I think it might be a captured asteroid. That will be my view. It's got sort of characteristics of asteroids that makes me think maybe it is basically just something that wandered too close to Mars and got captured. Yeah,
I'm leaning that way too, but only because it seems more logical. I have no scientific backup to my claim, but anyway.
No, neither do I, really.
It's an interesting story. You can read about it in the monthly notices of the Royal Astronomical Society, as Fred said, or you can go to universetoday.com. This is Space Nuts, the podcast about astronomy and space science.
Roger, you're loud and clear here also.
Space Nuts.
And Fred, we're going a little bit further away than Mars. We're heading 57 light years away to an exoplanet. It's called GJ504b. This planet has got a couple of really amazing characteristics. One being it is pink. And the second being its atmosphere seems to be very, very salty. In fact, it could be the Himalayan salt planet. You just never know. Himalayan pink salt, very, very popular. It's a very strange one, and my wife would love to go there because, as I've said, she really adores salt. You give her a steak, put salt on it. Give her, vegetables, put salt on it. Ice cream. Put more salt on it. Yeah, she loves the salt. Now, I'm going to suffer a salt and battery if I keep talking about it like that. Tell us about this unusual pink planet.
Yeah, I'm glad you did the Himalayan salt thing, because if you hadn't, I would have done. Yeah, that's right. I don't know that the two are necessarily related. So it's there's quite a backstory with this. This is a planet. An exoplanet that is unusual in that we see it directly. As you and I have said many times, most exoplanets, we only infer their presence from the behavior of their parent planet, parent star. With this one, we can actually see it, which is how we know it's pink. We've known about it for 13 years, discovered back in 2013. But it's also a little bit of an enigma because its mass is about 25 times that of Jupiter.
Yeah. Salt's not light.
Well, notwithstanding the salt, we might get back to that in a minute. To some other salty tales. The thing is that if this object were just on its own in space rather than in orbit around another world, we wouldn't call it a planet. We'd call it a brown dwarf star because the criterion for an object to be a brown dwarf star is a mass more than 13 times that of Jupiter, because that's the mass at which some low-level nuclear reactions switch on that distinguish it. I think it's deuterium burning is the technical term. Distinguish it as a star rather than a planet. And so I think the only reason it's being called a planet is because it's going around another star. That you could, in fact, almost say it's actually a double star. But people don't seem to be saying that. I think it's because that 13 Jupiter masses is a fairly blurry sort of boundary for an object to be classified as a brown dwarf. Anyway, brown dwarfs are well known, well studied. They are this sort of interim phase where you've got low-level nuclear processes. You don't have the nuclear fusion that characterizes a genuine star. I've just noted a sentence in this very nice article about this from the Science blog, which puts it perfectly. It sums up just what I've said. It says, astronomers hedge their bets and call it a planetary mass companion. Oh. And that gets over the problem. It's a planetary mass companion rather than a planet and not necessarily a star. So there you go.
To quote Monty Python, you're just making that up.
we make it all up, Andrew. You know that, yeah. But they don't. You're right. They don't know that. So also interesting because it's cool. So that most of and I mean cool in a temperature sense rather than its presence on social media. It's most of these objects like brown dwarf stars are well over 1,000 degrees Celsius. This one is only 290 degrees Celsius. And once again, going back to that Science blog article, they've said that's about the temperature of an oven baking bread. So, which is warm by terrestrial standards, but not by space standards. And so we've got this object, which is a mystery. But the reason it's in the news is because there have been studies with the James Webb telescope. Apparently this object has been studied a great deal in the 13 years that we've known about it. But it's some observations now made with the James Webb Space Telescope, which continues to amaze us because of its capabilities. And the spectrum of its atmosphere, of course, reveals these different spectral fingerprints. We talk about that a lot on Space Nuts, and it's what I used to do for a living. The spectral fingerprints of stars and galaxies. Anyway, observations with this revealed a spectrum that was very difficult to understand because it had features that didn't seem to make any sense. And it turns out that the trick was to look at different sorts of clouds that you might have in the atmosphere rather than just a clear atmosphere. Yeah. And it was when they basically tried to fit the spectra that would be produced by different types of clouds to what they were observing with the Webb telescope that these authors who've done this research found that the best fit was salt clouds.
Yeah.
And now I find it hard to imagine whether those are clouds of salt, of pure salt, in a solid form, or whether it's not salt vapor. I don't know. I don't think because at that temperature, it's likely to be solid salt.
Wow. That's wow. I'm going to show this to my wife. She'll be very, very excited.
Will. It's drifting. It's drifting in the air.
So I could go out there now and say, they've found planets that are made of diamond.
Yes,
and
they
they've
have.
found one made of salt. She said, "We're going there."
Yeah. Yeah. There you go.
I'm taking the mickey, but yeah. Anyway, I just thought of something which I probably should have said at the time, but it can't be a brown dwarf. It's got to be a planet because it's not the right color.
Yes, being pink, it is not brown, is it?
We could have discovered a pink dwarf.
Yeah, well, maybe that's what it's going to be classified as, because the color itself must relate to what it looks like, to the sorry, that's a tautology. The color relates to the constituents of its clouds. That's what I meant to say, really. Yeah.
Well, when you look at Jupiter, I mean, it's in the red spectrum too, isn't it, really? So
yes, it is. It's got, and Saturn as well. They've got colours that really, that in a sense, they're what we might describe as warmer colours, although the temperature goes the other way. The warmth of the colour relates to something called the colour temperature. And the higher the colour temperature, the more white and brilliant objects are, whether they're stars or lumps of metal or whatever. But yes, so a pink one, it's the pink in a way matches the low temperature of this, and because anything that's glowing would have colours that would characterise what its temperature is. So I think we've solved one mystery there, Andrew.
Maybe so. Yes, I knew we'd get somewhere sooner or later. Yeah, we always endeavour to adequately deal with these issues.
Yes, that's right.
Yeah, but no, it's a really fascinating planet, and well worth reading that story. It's cool. It's pink. It's salty. I mean, that sounds very provocative.
Actually, it sounds like Scottish porridge.
I've had that. I had that last year when we went to Edinburgh.
Yeah.
I loved it. It's very nice.
Salt, yeah. I had my porridge this morning, but I put honey in it. Sorry.
It just reminds me, they have a drink called salt coffee in Vietnam.
Okay.
Which is, it's to die for.
Is it?
It is, yeah. We got addicted to it. We had it every day while we were over there.
Interesting.
It is really nice.
Is it just coffee with salt in, or
no? It's a shot of coffee, then condensed milk, and then cream, salted. And they give it to you, and it comes in 3 different layers, and then you just stir it up and drink it. And we had it iced because it was so hot over there.
Yeah.
But you can have it hot as well. It's delicious. Yes. And then you have a heart attack.
Yeah, which is less delicious.
Yeah. No, very nice. But there you go. If you want to read about the salty exoplanet, you can do that at scienceblog.com. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Space Nuts.
Our final story, Fred, is about a swift mission to save a vital space observatory. This story I've seen popping up a few times in recent days, and it's because of the timing issue they've got with this. They've got to act very swiftly to save the Swift Observatory.
That's right. It's a swift story. A story we'll cover swiftly at the end of the show. It is. It's a great story.
It is.
And what's making...
For all the wrong reasons, it's a great story.
Yes, that's right. What's making the headlines is that engineers and scientists have been able to do what they've done. And in fact, the main a proponent of this is a company that only started in 2020.
Yeah.
And so it's basically a response to NASA saying, help, we need help.
Somebody pitch an idea to fix this problem.
Yeah, and this company, Catalyst Space Technologies, did. So the background story here is that Swift is a satellite which has actually been in orbit, I think, since the early 2000s. I can't remember the exact year, but it's a venerable spacecraft. Its job, November 2004. That was when
20th of, in fact.
Indeed, the 20th. Lots of twos there,
Yeah.
zeros. And it's and Swift. So it's a spacecraft that has basically proved its worth in a big way, and its mission was and remains to detect gamma ray bursts. And these are bursts of gamma rays, as you'd expect, that we now know come from probably colliding neutron stars, things of that sort, really energetic phenomena in deep space. That they themselves have an interesting history because gamma ray bursts were not known before the 1970s. And it was when various agencies launched spacecraft that could detect gamma rays in order not to look at the universe, but to look down on the Earth to make sure nobody was actually breaking the agreements of the nuclear test treaty and basically doing nuclear testing in the atmosphere. That was what it was all about. It was to guard against maverick nuclear tests in the Earth's atmosphere. But it didn't discover any of those, but it did discover a whole new cosmic phenomenon. And the thing about gamma ray bursts is the gamma rays itself don't tell you much about it except what direction this thing lies in. And so Swift, and its name is very well chosen, was a spacecraft that was designed to give swift measurements to the astronomical world so that they could very quickly turn their visible light and radio telescopes onto the place where this gamma ray burst had emitted and essentially sense an afterglow, what we call the optical counterpart in the case of visible light. And it's the optical counterpart that lets you do the astrophysics. It lets you make the measurements that you need to know how far away it is and what's been going on there. It's been a long time coming, our understanding of what's really going on with gamma ray bursts. For a long time, they were a complete mystery. Anyway, Swift as a satellite has got this fabulous track record, but it does not boast in its retinue of instruments. It doesn't boast any thrusters. And it does seem like in modern, our modern understanding of the way you put a satellite into orbit, you want to have something that will actually let you shift its position or its height, even if it's only to get out of the way of the nearest Starlink spacecraft that's going to collide with it if you don't. Yep. So it doesn't have thrusters. It would belong to an earlier era. And of course, its initial orbit, I think, was something like 600, getting on for 600 kilometers. That was its early orbit, 585 kilometers above Earth. But over the decades, and there have been a couple of them, that orbit has deteriorated because even at that height, there is still a trace of the Earth's atmosphere. And so that trace of atmosphere is enough to break the spacecraft, B-R-A-K-E, not B-R-E-A-K, which will slow it down. And of course, as you slow it down, it descends. And as it descends, it hits more atmosphere, which slows it down even more. And then it descends even more. And you're on this pathway to a re-entry. It's currently I think flying at 363 kilometers. So that's quite a long way down.
That's a big deterioration in its orbit.
It is, that's right.
Yeah.
And that deterioration will not just continue, it will increase as it experiences a thicker atmosphere. It's not helped, actually, by the fact that the sun's been pretty active over recent years. We've seen a lot of solar flares and coronal mass ejections and things of that sort. And we know that as the subatomic particle flux from the sun increases, which it does in these events, it tends to kind of fluff up the Earth's atmosphere. it raises its height. In fact, SpaceX fell foul of that some years ago when a number of the spacecraft that they launched didn't actually make it into orbit because the Earth's atmosphere was puffed up by solar activity. So that's been happening, and that's increased the risk of re-entry for Swift. So along come Catalyst Space Technologies and said, we can do it. And they've actually built and prepared, I think, along with collaborators, a spacecraft which will be launched actually later this month, I think in about 5 days at the time we're recording this. If I've read my notes on this correctly, it will go to orbit. It will actually be an air launch, one of these fairly rare launches where you carry a rocket underneath the belly of of an aircraft, take it up to 39 or 40,000 feet, then release it. And the rocket burn then takes it up to orbital speed. It's a great way of choosing just exactly where you want to launch from, which often has an impact on the orbit that the spacecraft will go into. So that's what's going to happen.
That's how they used to test the space shuttles initially. And drop them off a Boeing 747.
That's correct. They did, to get their landing characteristics. And actually, a company called Virgin Orbital, run by Mr. Virgin, Richard Branson, was all set to kind of capture that market, but they had a failure a few years ago when they tried to launch from Cornwall and in fact wound up the company. So that company doesn't exist. There are still other companies doing the same sort of thing. Anyway, we hope that the spacecraft that will be launched, which, if I remember rightly, is called Link, will link up with Swift. I think it's got 3 robotic arms that will grab onto the Swift spacecraft, and it will then fire its rockets in order to push Swift into a higher orbit. And it may even stay attached so that we've got perhaps future opportunities to increase its orbital height again. Yeah.
If they do not succeed, and I'm not going to put the mocker on them, but if they don't, it's likely to come crashing down late 2020s, early 2030s. But we've got to get to it faster than that, because once it gets within, 300 kilometres?
Yeah.
All bets are off.
Yes, that's right. It's too hard.
It's getting pretty darn close to that now.
Yeah, it's not far off. That's right.
So they have to have this mission up and done by, I think it's October, isn't it, or something like that?
Yes, that's correct. It's got a good deal of urgency about it. I think NASA is extremely pleased that this company's risen to this and been able to do it. And so I guess what's happened is you built slightly higher levels of risk into the whole process of designing and manufacturing it, that would not necessarily be acceptable if you were doing things the conventional way. But by cutting some of that risk aversion, if I can put it that way, you would save time.
All right. Well, we wish them well. It's going to be exciting either way, but hopefully, fingers crossed, they'll be successful and Swift will keep on keeping on. We will know very, very soon. They've got no time to muck around with this one, so we'll keep our fingers crossed for them. And you can read all about it at arstechnica.com, arstechnica.com. And that just about wraps it up. Fred, thank you so much.
It's a pleasure. It's always good to have some great stories, Andrew.
Yeah, they were fun.
We usually do.
Lots of fun.
Yeah.
And I know where our next planet or our next holiday will be going to.
The Pink Planet.
The Pink Planet.
Yes, that's right.
Yes, we might be able to get that company to build us a rocket. Catalyst.
They could probably, if you told them now, you could be away in a couple of weeks.
Could be easily, yeah.
It's only 57 light years.
Plenty of time to sleep. Probably permanent sleep. Never mind. Thank you, Fred. We'll catch you next time.
It's a great pleasure, Andrew. See you soon.
Professor Fred Watson, astronomer at large. Don't forget to visit us on the online between episodes at spacenutspodcast.com or spacenuts.io, and you can leave messages through the Ask Me Anything button, or visit the shop, or become a supporter, or whatever you like, or just have a look around. The shop's lots of fun. Just pop in there, browse. You won't be able to say no. And thanks to Hugh in the studio, who couldn't be with us today because he wasn't swift enough.
Oh.
Boom, boom. From me, Andrew Dunkley. Thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.